Okay, so now we're going to look at times where we may have an imaginary solution to a quadratic equation. So here's an example of a parabola that does not cross the x-axis. So we would say no real solution. Now, just because there's no real solution doesn't mean that we can't use algebraic methods to solve this equation and then have an imaginary solution. So, when we see a situation like this, where the parabola does not cross the x-axis, there's no real solution, which means there's an imaginary or complex solution. Let's look at some examples of quadratics with imaginary solutions. First, we have x squared equals negative 144. Well, we learned last week that in order to solve for x in this case, we take the square root of both sides. The square root of x squared is x. And then we have negative 144. I can factor out an I. Okay, and negative 1 actually is what I should put underneath the radical. And then I have the square root of 144. The square root of negative 1 is I. The square root of 144 is 12. I didn't leave enough room here to put my 12 in front. And then don't forget, when we take the square root and we're solving, we always write plus or minus in the front. So the solution to this equation is plus or minus 12i. Let's try one more like that. Let's see here. I think the first thing I'm going to do is subtract 90. There's a couple different ways you can get started with this one. So I'll have a 5x squared equals negative 90. Now I'll divide both sides by 5. Maybe you chose to do that first when you saw this problem. So 90 divided by 5, 18. So we have x squared equals negative 18. Now that we have just our x squared, I'm going to take the square root of both sides. The square root of x squared is x. The square root of negative 18 is the square root of negative 1 times the square root of 18. So square root of negative 1 is I. Square root of 18, there's a perfect square that goes into 18. That's the square root of 9 times the square root of 2. So I've got a lot going on here. So in my answer, I need to include I, the square root of 9, which is 3, and the square root of 2. And then I have to remember to put my plus minus in front. 3i root 2. Now, not all of our solutions are single term solutions. Notice, we're not adding or subtracting anything onto this. Sometimes we do have that. And then what we call it is a complex number. A complex number is a number that has a real part and an imaginary part. And those two parts are either added together or subtracted from each other. So you can see in the chart here that there's some examples of real numbers. Those are the numbers you've worked with your whole life. Then on the right, there's an example of imaginary numbers. Okay, so that's any number with an I. And then on the outside are complex numbers. We have both a real part and an imaginary part. Notice all of these complex numbers have an addition or a subtraction symbol with them. We're going to do a few more examples together of solving quadratics, and this time we will have complex solutions. Before we get there though, you can graph these, okay? If you were to graph these solutions, you'd have a real axis and an imaginary axis, and you would plot the point from there, as you can see on this graph. We're not going to do that, but I just wanted to put that out there, that imaginary graphs or complex graphs exist. Okay, so we're going to find the zeros of each function. Whenever I'm asked to find zeros, I like to try to factor it first. I know that I have to put this equal to 0, so I've got my 0 there. And I'm going to think what multiplies to 26 and adds to 10. I wish it was a 24, but it's not. So there's nothing that multiplies to 26 and adds to 10, so factoring is not going to work. So my next option is to complete the square. Remember, when we complete the square, the first thing we do is separate our variable terms from our constant terms. Okay, negative 26 equals x squared plus 10x. I have a coefficient of 1, so I don't have to do any dividing. So now I complete the square. Half of 10 is 5. 5 squared is 25. So I'm going to add 25 to both sides. And now I have negative 1 equals x plus 5 quantity squared. Now I'll take the square root of both sides, because now I'm solving. The square root of negative 1 is plus or minus I. The square root of x plus 5 squared is x plus 5. Subtract 5 from each side, and x is equal to negative 5 plus or minus I. So very similar to our work from last week with completing the square. The only difference is when we take the square root of our constant side, we're going to see an imaginary number. I've got 2 more here for us to practice with. Put it equal to 0. What multiplies to 12 and adds to 4? Nothing. We're back to completing the square. Let me switch colors so it's easy to see the difference between my work. Subtract 12 from both sides. Negative 12 equals x squared plus 4x. Again, I have a leading coefficient of 1, so I'm ready to complete the square. Half of 4 is 2. 2 squared is 4. Add 4 to both sides. Negative 8 equals x plus 2 squared. Now I'll take the square root and start solving. Okay, so negative 8. There's a few things to simplify here. First of all, I know that I've got the square root of negative 1, so I'll have an I. I also know that 8 is 4 times 2, and I know 4 is a perfect square. So on the left, I'm going to have the square root of 4 is 2, I, square root of 2, and then I have to have my plus or minus as well, equals x plus 2. Now I'll subtract 2 from each side. And my answer will be x equals negative 2 plus or minus 2I root 2. Lots of 2's in this answer. It's okay. All right, I've got one more for you to try. I'd like you to pause the video and try it on your own, and then come back and check your answer. Okay, so I'm subtracting 5 from both sides. Now I'm going to complete the square. I take half of 2 is 1. 1 squared is 1. So I have negative 4 equals x minus 1 squared. Take the square root of both sides. The square root of 4 is 2. The square root of negative 4 is 2I. And when I'm asked to solve, I always put that plus minus there. The last step will be to add 1 to both sides. X is equal to positive 1 plus or minus 2I. Now, remember we talked about this last week. I just want to make one more note of it. Let's say you wrote your answer out in reverse order from me. Let's say you wrote your answer as x equals plus or minus 2i plus 1. That is not wrong, okay? I would not mark you wrong on your test as long as all parts are written clearly and they're spaced out appropriately. But this is the best way to do it, by putting your real part first, your complex part second. So this is what I'm hoping you'll get in the habit of doing. So I just wanted to take a moment and make that point. So that's it for this week. So simplifying when we have a negative square root, solving when we have x squared equal to something negative, and then solving quadratic trinomials when we have complex solutions. So to summarize this, I encourage you to take a minute and see if you can give some examples of your own of real numbers, imaginary numbers, and complex numbers. Your assignment is chunked a little bit because there are a few pieces that we skipped in this unit. So notice you'll skip after 25 to 28, and after 31 you'll skip to number 36. Okay? If you need help with any of this, make sure you're coming to office hours and we can go through some examples together. Have a good week, everybody.